Have you ever just looked up at the sky and thought, why here? Why this universe? Because, when you really dig into the physics of it all, it starts to look less like a random accident and a whole lot more like the universe was somehow built just for us. It's a wild idea. So what's going on here? Let's get into it.
To really get your head around this, let's just flip the whole question. Imagine for a second, what if the fundamental rules of our cosmos were just a little bit different? A tiny tweak here, a small adjustment there. Well, as we're about to see, even the smallest change would mean a universe with no stars, no planets, and definitely no us.
Physicists have a name for this. They call it the fine-tuning problem. But honestly, you can just think of it as the ultimate Goldilocks story. Everything in our universe seems to be not too hot, not too cold, but just right. And when I say just right, the level of precision is absolutely staggering. Okay, for example, let's look at the force that's pushing our universe to expand, the cosmological constant. Our universe has a value that's just right, allowing gravity to pull matter together to form all the galaxies we see. But if that number were even a little bit bigger, the universe would have just flown apart way too fast for a single star to ever form. It'd be nothing but a cold, empty void. And it doesn't stop there. Here's another one that'll blow your mind. The strong nuclear force, right? It's the stuff that holds the center of atoms together. Now, if you dial that force up just a tiny, tiny bit, poof, all the hydrogen in the early universe gets cooked into helium. No hydrogen means no water. No hydrogen means no stable, long-lasting stars like our sun. It would have been a completely different and totally lifeless place. So you see the pattern here, right? From the biggest scales of cosmic expansion down to the tiniest parts of an atom, it's the same story. Our universe is balanced on a razor's edge. This quote really nails it. The numbers look like they were fine-tuned to permit the emergence of life. It's this whole set of cosmic coincidences that just screams for an explanation.
So what are we supposed to make of all this? Is this just how our universe is and we should just accept it? Did we just win some cosmic lottery with odds that are basically impossible? Or is there a better answer to this puzzle? This is where the thinking starts to get really, really interesting.
So, one of the first big ideas to try and solve this is called the Anthropic principle. And it's a really subtle but super powerful idea. It basically flips the entire problem on its head by forcing us to consider our own role in all this, just as observers.
Here's the core of it. We shouldn't be surprised that we find ourselves in a universe that can support life. Why? Because if the universe couldn't support life, we wouldn't be here to notice it in the first place. It's called an observation selection effect. Of course we observe a universe with life-permitting laws. All those other possible universes, the ones that are totally sterile of empty, well, there's nobody in them to wonder why. Now this idea comes in two main flavors. The weak version, the one on the left, is pretty easy to swallow. A no-brainer really. It just says our location is special. Of course we live on a nice cozy planet and not, inside a star. But the strong version, whoa, that's a whole different ballgame. It says the universe itself, its actual laws of physics, must be the kind that allows for observers like us. And that raises a much, much bigger question. How could that possibly be? Well, to make sense of that radical, strong anthropic principle, a lot of physicists turn to an even more mind-bending idea. That we're not just lucky, we are literally the winners of a cosmic lottery. The thinking goes something like this. If our universe is the only one that exists, then its fine-tuning is this huge, baffling mystery. But what if it's just one out of trillions and trillions of others? Suddenly, the mystery starts to fade away. I mean, think of it like a giant cosmic gumball machine. It's just endlessly churning out universes, and each one gets a totally random set of physical laws. Most of them are duds. They're sterile, empty, and fall to the side. But hey, if you crank that handle enough times, you're eventually going to get one that's just right for life. Our existence isn't some miracle. It's just what happens when you have enough chances. It's a statistical inevitability. And you can see the appeal, right? The multiverse takes what looks like impossible, insane luck, and turns it into simple, boring probability. It feels like a clean, scientific way out of the problem, one that doesn't need to talk about purpose or design or anything like that. But is it really that simple? Some philosophers are now arguing that this super elegant multiverse solution is actually built on a very subtle but very critical logical mistake.
Okay, this is where the debate gets really fascinating. The accusation here is that people who believe in the multiverse are accidentally falling for something called the inverse gambler's fallacy. It's a bit of a mind-bender, for sure, but it cuts right to the heart of the whole argument. Okay, so we all know the normal gambler's fallacy, right? It's thinking that if you've lost 10 times in a row, you're due for a win. Well, the inverse fallacy is seeing a surprising win,
like seeing someone walk up to a dice table and roll a double 6 on their very first try, and concluding that they must have been secretly rolling the dice for hours beforehand. But that one roll you saw tells you absolutely nothing about any previous rolls you didn't see.
This thought experiment makes it way clearer. So imagine Jane exists because of an IVF procedure. She then finds out that her existence depended on a doctor rolling a double 6 with a pair of dice. Her flawed conclusion? She thinks, wow, there must have been tons of other doctors rolling dice for other potential people who failed. But that's the fallacy. Those other hypothetical attempts have absolutely no bearing on the probability of the specific dice roll that created her. She's mixing up probability with explanation.
And that is the big gotcha for the multiverse argument. The critique is that all we know for sure is that our universe got the cosmic double 6. Just imagining a bunch of other, failed universes doesn't actually make the odds of our universe succeeding any better. The critics say the whole multiverse argument might just be a perfect example of this exact flawed reasoning.
So, this brings us right to the core of the whole disagreement. And it's not just about logic anymore, it's about the fundamental nature of our universe. Was it a product of pure chance, or was it somehow inevitable that it turned out this way?
Right, so this is where we're at. Are the laws of our universe contingent? Meaning they're like a dice roll and could have easily been different. If that's the case, then the multiverse argument is wide open to that gambler's fallacy critique. Or are the laws essential? Meaning they couldn't have been any other way, just like a diamond has to be hard. That approach avoids the fallacy, sure, but it leaves us with an equally massive mystery. Why is this specific life-friendly set of rules the only one that was ever possible?
And what's really fascinating about all this is that our best scientific theories about the multiverse, things like eternal inflation and string theory, they actually support the contingent view. They propose that our little bubble universe was formed by random chance, and its laws could have been totally different. So, ironically, the most popular scientific theories are precisely the ones that are vulnerable to this huge philosophical critique.
So let's just take a breath and recap where we've been. We started with this universe that looks almost impossibly tailor-made for us. The multiverse came along and offered a really neat solution, a cosmic lottery that we were basically guaranteed to win. But then we found that that very solution might be built on a sneaky logical fallacy. And that leaves us right back where we started. But now we're facing an even deeper question about the very nature of reality itself.
And in the end, this is the question we're left with. The fine-tuning of our universe is still one of the deepest, most profound mysteries in all of science. It forces us to ask, are we the result of just a lucky accident in an endless multiverse? Or are we part of a story whose rules were written from the very beginning? The answer is still out there, somewhere among the stars.